Okay, so today we're going to start section 3.2. Well, I guess spend 2 days on it, so not forever this time. And we're going to talk about, today we're going to talk about Rolle's theorem. Rolle was another French mathematician, okay? And it all kind of pertains to these max and mins. Okay? So this is, we'll come back to this. We're definitely, I'm not going to, you can like leave space if you want to rewrite this in your notes. Otherwise, we'll just write C sheet, something like that, see the theorem sheet. So but then we'll put all our examples in our notes, right? Or in our notebook. Really, the only notes would to actually be to write his theorem. So we'll just cover that and then we'll go right to examples. Okay, so section 3.2, part 1, we are dealing with Rolle's theorem. And then we can put C sheet, C theorem sheet. Or if you want to leave a little space and write it in there, if you think you might lose a sheet or something, you can leave a little space and then later on you can just copy it in. All right, so let's go to this theorem sheet and see what Rolle's theorem says. All right, so it says, I'll slide it up either. Let f of x be a function. It has to satisfy these 3 hypotheses. Okay, so we have to, it's kind of like a checklist. You have to make sure that f of x is continuous on the closed interval, and they'll give you this interval. Okay? Continuous just means, right, it's closed, there's no space, there's no time where you pick up a pencil if you're tracing. Okay. And then the function is differentiable on, notice it's on the open interval. So for 2, I like to find the derivative and see where the derivative, or if the derivative doesn't exist. So if the derivative doesn't exist at a certain location, then the original function is not differentiable. Does that make sense? You look at the derivative and you see if there's an issue with the derivative. If there's not, then that means that the original function was differentiable. Okay. Then notice for 3, you go back and f of a has to equal f of b. Okay, and a and b are the start and stop of your interval. This is back on the original. So kind of like 1 and 3, let's do it in red. 1 and 3 deal with f of x, and then 2 and 4 deal with the derivative. Okay, even though 2 says f of x is differentiable, in order to determine that, I like to look at the derivative. Okay, so for 2, I take the derivative. All right, so if those 3 things are met, then there is a number c in this interval such that it will make the derivative equal to 0. There is a number that makes the derivative equal to 0. And why do we like that? What do we care about a derivative equal to 0? What'd you say? Okay, it's a critical, yeah, I like it. It's a critical number. And what's happening at critical numbers? Peaks and valleys. That's what we're caring about, peaks and valleys. So he's kind of trying to determine another way where we can kind of determine a peak and valley. This 3 is kind of important. F of a equals f of b. So let's just draw just a little bit of a graph. Here's a and here's b, right? If those are the same height, if they're the same height, I can no longer just have this slanted line like we were talking about. If f of a equals f of b, so those 2, that's part 3. Those 2 have to be the same. Now think about it. How am I going to get from a to b? Okay. Maybe I curl up like this. I have a max. Okay. If I curl down, we could do another one. If I curl down, remember they have to be the same height. So, you know, and I could cross. It could go all the way down here. But if I come back up, I have a min. Can you see that? What else? There could be more than 1, right? As long as they're the same height, you know, it could go down, up, and that's okay. He's guaranteeing at least 1, but there could be more. So that f of a equaling f of b kind of reassures that, okay, now I've got some curves going on. I can't just do it as far as a line. Does that make some sense? So that third step is actually fairly important. All right, so let's look at some. And I'll reference this back. So let's see, what are the directions? Verify directions are a little long. Verify that the function satisfies Rolle's theorem. Verify that the function satisfies Rolle's theorem. Okay. Oh, let's see, I changed the directions just a little. Okay. If it passes, find all numbers C. Now, what is C? C would be, let's even go back to our drawing here. Do we know what C would be? C would be that critical number. C would then be this guy here. C would then be this guy here. C is the X value where this peak or valley is happening. Okay. And technically, I mean, here we would say we would have like C1, C2, and C3. So we said find all the C values. So I think in our examples, we only see one each time, but there could actually be more than one. All right, find all numbers C that satisfy the conclusion of Rolle's theorem. If it fails, you know, we don't really have to do anything. We just have to say, hey, it doesn't work. So the easiest way, I just program this in. If it fails, then I had us type does not exist. Just because we're kind of used to that. Technically, it can exist, but it doesn't exist under his restrictions. Does that make sense? So we're going to say it doesn't exist as far as following Rolle's theorem. It may still be out there, but it doesn't exist following his theorem. So his C does not exist. All right, let's look at some. We've got 6 if we can make it. All right, first one is, okay, let's look at x squared minus 6x plus 1, and the interval is from 0 to 6. Can we pause? How do we do on the directions? They're a little lengthy. Okay, so what we have to do, we have to verify that the function satisfies Rolle's theorem. So we have to go through, and especially on the test, you must go through and show me that you did steps 1, 2, and 3. Okay? So what is this going to look like? So you need to say that this is a polynomial. Why do we like polynomials? They're always continuous. Yeah, there's no problems, right? Very, very few problems. So for 1, we're just going to say polynomials are continuous. We probably could say their derivatives are also not a problem, but let's go ahead. Step 2 says f of x is differentiable on, and notice this will come into play a little bit later. Notice it has to, f of x has to be continuous on the closed interval, but only differentiable on the open. So that means the endpoints. We get a little bit more lenient. We don't have to worry so much about the actual endpoints and stuff too. Okay? But to kind of show that this is differentiable, I like to find the derivative. So let's find the derivative. What's the derivative of our original? Roll it down, subtract 1, 2x minus 6. And if there's no problems there, that means the derivative always exists, which means f of x, the original problem, was always differentiable. Okay? So how do we want to say that without writing too much? Let's write always differentiable. Therefore, we could just put the little dots. Therefore, f of x is differentiable. Therefore, f of x is differentiable. Okay. All right, so let's do step 3. We said step 3 is fairly important as well. We have to show that f of a, should we go back to here? Do we see what we're doing? F of a equals f of b. We have to say that they're the same height. Right? We have to say they're the same height, so we got to do f of 0, and then we have to do f of 6 and show they're the same. Make sure you don't go to the derivative. Make sure you go back to the original. So we just plug a 0 everywhere there's an x. And that gives us, I want you to at least show that you did it. So maybe write that, but then if you just want to type it into your calculator, that's fine. That should give us 1. And then let's go back. Remember, you go back to the original. We're out of room. Oh, we don't need the drawers. All right, so now we're going to do f of 6. F of 6, so that you might, I don't know, do you need a calculator? 6 squared minus 6 times 6 plus 1. This would give you 36, and this would give you minus 36. So that takes you to 0 and then plus 1. So you want to show that they are the same. F of A and F of B are the same. So they are the same height. So if it's continuous, it's always differentiable, and they're the same height, you must have a derivative, a value for x, that causes the derivative to be 0, which is telling us there must be a peak or valley. Okay? So now let's show that it satisfies. So we're going to take the derivative. Should I back it up? If it passes all, okay, which it did, 1, 2, and 3 were all good to go. Then we're going to find all numbers C that satisfy the conclusion of his theorem, which said, what's the conclusion of his theorem? That there is a C value that causes the derivative to be 0. So let's take the derivative. Make sure you take the derivative. Is it still on an angle? And let's find that C value. When is the derivative equal to 0? When is the derivative equal to 0? So add a 6, divide by 2, and what is that x value or C value is 3. So what's happening at 3? Either a peak or valley. Makes sense, especially going back to remember, once you prove that A and B are the same, then you got to either go up and come back down or go down and come back up to come back to B. All right, good. All right, let's try another one. The only thing is we don't know much about it, right? We don't know if it's a peak. We don't know if it's a valley. We don't know if it's an absolute. But at least we found something, and then we can kind of go from there. Even if you graph it, you know, sometimes it's like you don't even see the whole graph. So you could, something's happening when X is 3. So now you can adjust your windows to make sure that you can find something at 3. So there's some value to it. All right, let's do f of X. Can we see it? Is it at an angle? Okay. F of X equals X to the third minus 2X squared minus X plus 2. And then the interval is from 1 to 2. That's kind of interesting, because if it passes 1, 2, and 3, then I have a max or min that is not an integer, which is maybe, slightly annoying, yes, but also good to know that, okay, something's happening between these nice numbers, and I got to go a little bit deeper as to what that value is. All right. So on the test, though, you are going to have to go through 1, 2, and 3. You won't have to memorize it. You'll have this paper for the test. So you just are going to have to go through and make sure that you said, yes, I went through 1, 2, and 3. So 1 says, is it continuous? Polynomials, it only has to be continuous from 1 to 2. But polynomials, always continuous. Okay, so polynomials, it only has to be, polynomials are always continuous. But really, don't forget that it really only has to be between 1 and 2, including 1 and 2. But, okay, for 2, is there any issues with the derivative? So I like to look at the derivative. All right, so what is the derivative? Roll it down, subtract 1. Roll it down, subtract 1, we get 4x, and then minus 1, and the 2 goes away. All right, what is 3? Now, are we okay? Do we understand that we're just going through this? Oh, let's state something, right? The derivative is a polynomial, right? You can always find a derivative. Maybe that would be a better way to say it. There is always a derivative. There is always a derivative. Maybe I like that better. There's always a derivative. Therefore, I like that better. There's always a derivative. Therefore, f of x is differentiable. That makes more sense. Always a derivative, so that means the original then was always differentiable. Just something, just so that I know that you at least thought about it. Okay. And it's okay to say, well, no, that's right. We'll leave it. All right, so now let's do 3. But you want to say something that you looked at the derivative and you saw no issues. I would be okay on the test if you did this and you wrote no issues. That's fine with me too. Just something so that you knew. I mean, yeah, that actually, I like that too. There's no issues, right? You can always find a derivative. There's no issues. So that's fine if you just want to mark that. Okay, so now 3 says, don't forget, then you just look at your paper. 3 says you got to do f of a equals f of b. So f of a is, do we know that a is 1? Are we okay with that? This guy's a, this guy's b. And I want you to show me that you at least knew to plug it in. But then obviously just grab a calculator. You can kind of work it out in your head, whatever works. This gives us 1 and that cancels. This gives us -2 and that gives us +2. So that it should be 0. So now what am I hoping for an answer? I'm hoping that f of 2 also gives me 0. So now I kind of know the answer, but I got to make sure it does work. 2 to the third minus 2 times 2 squared minus 2 plus 2. And sure enough, that works too, doesn't it? This gives me 8, and then this would be -8. And then the -2 and +2 cancels everything out. If you use a calculator, that's okay. Just even for the fact just to make it go quicker. All right, so f of A does in fact f of B. So we've met all the requirements. Okay. Rule says if you, he's like giving you a warranty or a guarantee. If these three things are met, then what is he guaranteeing us? The derivative. There is at least one value where the derivative between these numbers, where the derivative equals 0. So Roll says as long as 1, 2, 3 is met, I'm going to guarantee you that your derivative will equal 0, specifically between 1 and 2. So now we just have to go find it. So chances are, if it falls between 1 and 2, maybe it would be factorable with like, it could turn out to be fractions, but I think we have to use, how do we solve a quadratic if it's not factorable? Quadratic formula. So this is A, this is B, this is C. X equals, because that's what we want, or X or C equals. Opposite of B, should I write it? I'll write it here. Opposite of B plus or minus the square root of B squared minus 4AC all over 2A. All right, so the opposite of B, so what I'm actually going to write down a positive 4. Are we okay with that? Opposite of B, so actually B is negative. So we actually want to write down a positive 4 plus or minus the square root of B squared negative 4, but you're squaring everything, including that negative. So if you just want to write down 4, that's okay, because you're going to square it. B squared minus 4 times A, and then C is negative. So just take your time with all those negatives. And then remember the whole thing over 2 times A, the whole thing. Okay, so let's clean it up. 4 plus or minus the square root and then all over 6. And so now you just want to grab a calculator. 16 minus 4 times 3 times negative 1. So it would actually be what? 16, those two negatives gives you a plus. So 16 plus 12 takes us to 28. You're not getting 28. Don't make this harder than it is, but for some reason, going from here to here, that's our #1 mistake. So take your time. You can just type this whole thing in. Most calculators now do order of operations for you. Okay, so take your time with that. Okay, now a couple things. This answer isn't too bad. We can simplify the square root of 28. 2 goes into it. As soon as 2 goes into it, I try 4, because 4 is a perfect square. And then 4 times 7. So almost done. 4 plus or minus 2 comes out. The square root of 4 is 2, and then you still have the square root of 7 over 6. I don't think the one on the homework, you don't have to simplify it. But I don't know. I'll have to double check. All right, so remember, you cannot cancel the 4 and the 6. But you can, and you cannot cancel the 4, the 28, and the 6. But you can cancel the 4, the 2, and the 6. Okay? So it's got to be all 3 spots, and the number has to be outside the radical. So 2 plus or minus that goes to 1, so square root of 7 all over 3. You see that? You can only cancel the 4, the 2 on the outside, and the 6. You must do all 3. Okay, now, couple things. How many answers do I really have here? 2. So normally on WebAssign, we would type it in like this. Now, why do I say normally? Does anyone know why this is X, which is the same thing as our C? One of those gets tossed. Yeah, and now, are both of these max and mins? Probably. But technically, he's only guaranteeing us in this interval. So if you grab a calculator, I think this one is a negative number. This is negative 0.215, okay, and this is 1.549. So don't, unfortunately, we had to toss this. It's kind of like you almost kind of put on the side burner, like, yeah, it's probably pretty good, but technically, if we're talking about Rolle's theorem, he's only guaranteeing us between the interval that was given, so between 1 and 2. So we're only going to type this guy in. Let's write this maybe. Instead of just crossing it out, let's write not in given, and that was just given interval. See that? That's probably pretty important. The reason we're crossing it out is it's not in the given interval. Okay, how about, and this, to be honest, this might be overkill with his theorem, but I don't think the problems are too hard, so we'll be okay. Let's take a look at the next one. F of x equals x squared plus 5 over x minus 7, and the interval is from 6 to 9. So remember too, when you get to this one, you can have more than one C value for sure. But I think for ours, we only have one. So that'll kind of be another reminder to toss stuff. All right, what about here? First thing, is it continuous? It doesn't have to be continuous the whole time. It just has to be continuous on this interval. But where's there a problem here? We have a problem when x equals 7. Because, and how do we know there's a problem? When 7 goes in, what number comes out? We get undefined, right? We don't even care what the top number is, as long as it's at 0. But we get a number over 0 undefined. So that's a problem, right? Nothing is coming out. There's literally no point at 7. So x cannot equal 7. And sure enough, 7 is in the domain. So we can even stop and say not continuous on that closed interval. Doesn't matter if it's continuous anywhere else. It's only on that closed interval. If no matter what, x can't equal 7. But if my interval was 10 to 13, I'm going at it. Okay, but because the 7 falls right in the interval, we're done. We're not even going to continue on with Rolle's theorem. He can't guarantee us anything. Sure, there could be stuff going on, but as far as using Rolle's theorem, his warranty, his guarantee is done. So we're just going to put does not exist as far as Rolle's theorem. Okay. For Rolle's theorem, we can no longer 100% guarantee find a C, so we're just going to move on. We could put this if you want, fails Rolle's requirements. I like that actually. And again, that's just for your notes or something. For WebAssign, it's just going to be easy enough for us to do does not exist. Okay. But I want a little bit more why in this case, because basically it's failing his requirement. Okay, let's try this one. What are we at? We're on 4. 3 more if we can make it. All right, let's take a look. This one, f of x equals the square root of x minus 1/5 x, and the intervals from 0 to 25. So big interval, so not kind of as nice. I mean, it really is nice if we can get that smaller, but these numbers are actually kind of nice to work with, so I think they were being generous there. All right, so one says, is this continuous? Let's think about this. Square roots, when do square roots cause a problem? When they're negative. So as long as x is greater than or equal to 0, I'm okay. Technically, whatever's under the radical, but in this case, it's just x. So it is continuous on this closed interval from 0 to 25, 0 to anything, I'm okay. And what do you know, they started the interval at 0, so we're good. So it is continuous. F of x is continuous. Let's put on that interval. That's okay just to say that too, but maybe state somewhere that you thought about it. X has to be greater than or equal to 0, so we're okay. Not only is it not continuous, I mean, there's absolutely no graph, right, if x is less than 0. All right, so 2 says, now we got to look at the, now we got to look at the derivative. Okay, so let's look at the derivative here. First, I'm going to write f of x, because how do I want to rewrite this? I want to rewrite this as x to the 1/2 minus 1/5 x. All right, then let's find the derivative. Take your time with the fractions, roll it down. So 1/2 x to the, remember you subtract 1, so that gives us negative 1/2. And this guy's a whole nother term. That one's not too bad, even though it's still a fraction. It just goes then to 1/5. So maybe in our head, and maybe that's why we don't like negative fraction, or yeah, negative exponents, sorry, negative exponents. Remember, this means you got a 2 on the bottom and you've got a square root on the bottom. Let's take a look at that. Do we see how x to the negative 1/2 is a square root? The 1/2 is a square root, but because it's negative, it's on the bottom. Keep them separate too. Make sure that you're keeping them, these guys separate. Don't join them all together. They're 2 separate terms. Once we write it like this, though, what's a problem? X has to be greater than 0. So we got to take into consideration we can't have any negatives, but can it be 0? We see how 0 would cause a problem as well. Up here, 0 does not cause a problem. Down here, 0 causes a problem. But what is 2? 2 says it has to be differentiable on the open, which means it doesn't include 0. 2 says it has to be differentiable on the open. 0 is going to cause a problem. 0 is going to cause a problem, but it's okay because it's parentheses, not brackets. So it's not differentiable at 0, but we're okay. That means that f of x is differentiable on the open interval. You can't see any of this, can you? How about this? This, could you see that it has to be greater than 0? 0 is a problem. We could even just write that. The main problem, I mean, we kind of tossed all negatives out here to begin with. So really, the problem here, minus the, as long as we're in the domain, 0 is now a problem. 0 is a problem. You can't find the derivative at 0. But that's okay. It says it only has to be between those two numbers. So I clear it. Does that make sense? I cannot find a derivative at 0, but that's okay. That's exactly what this is saying. As long as it's between 0 and 25, then you're good to go. So we could even write that. No derivative when x equals 0. That's our problem. That's our problem, but it still clears it. It still clears it because it's open. If I couldn't find the derivative when x was 10, we're stopping. Okay? But as long as it's at the end point, that's okay. All right, so lucky us, that means we get to do 3, okay? 3, how are we doing? So 3 says, can we do f of a, f of b? Now remember, now we're going back to the original. So f of 0 and square root of 0 is 0, and then 1/5 times 0 is 0, so that gives us 0. How about f of 25? So the square root of 25 minus 1/5 times 25. Sure enough, this gives us 5, and this gives us 5. So that would, 5 minus 5 takes us to 0. This number can be anything, it just, this one has to match it. Okay? You just have to make sure they're the same. Okay, so now Rolle's theorem says we checked all 3 boxes. What is he guaranteeing us? He's guaranteeing us, we go back to the derivative. He's guaranteeing us that the derivative, there is an x value that's going to make it equal to 0. Now it's up to you. Let me slide this down. You can go back to either one. Let's go back to where we found the derivative. You can go back to either one. I actually kind of like this one better. This one's nicer to write. This one I think is nicer to use. If I just had to write the derivative, boom, I'm writing that one. But which one's actually probably easier to work with, especially if you have to solve for x? This guy. So remember 2, and then make sure when you, kind of like 4, when you go use his theorem, when you go find c, make sure that you use the derivative. What is he guaranteeing us? We are going to find an answer for x where the derivative equals 0. There could be more than one, but for most part, it's just 1. Okay, how do we solve this? I said this method was easier to solve, but we still got to do it. Anyone know what to do first? We're going to add 1/5 to both sides. So 1/5 equals, and this is kind of nice because now I have just one fraction on each side. So I'm going to actually cross multiply. Or you could just actually flip the whole thing over because 2 times the square root of x times 1 equals, and then it equals the other diagonal, 5 times 1, which is 5. Okay, 2 more steps, divide by 2. The square root of x equals 5/2. And then how do we undo a square root? Square both sides. Square both sides. So it's not necessarily a pretty answer, but x equals 25/4. Which better fall between 0 and 25. It does. It's a lot closer to 0, but working with 25 was nice. Also, maybe remember, we have to make sure that our endpoints equal the same thing. So maybe we were forced to use 25 there. That's the only way that f of a and f of b were equal. Good. Remember, this is the same thing as c. All right. How about how about f of x equals 2 plus x to the 4/5, and we're going from -1 to 1. Do you like that better? Yeah, that's a little better. Okay. All right, a 5th root, everything's good to go. You can have negatives under. Remember, this means you're going to take something to the 4th power, which would negate all those negatives anyways, but you can take a 5th root of negative numbers. Any odd root, everything's okay. So this is continuous. This is actually always continuous. There's no issues there at all. So f of x is continuous. There's no issues there. And specifically, it only has to really be from -1 to 1. All right, how about 2? What's the derivative? This guy goes away. Beautiful. This guy, right, roll it down, subtract 1. which takes us to, go ahead, yes. Did you say negative 1/5? Yeah, go for it, yeah. Okay, remember, that's my answer if I just have to walk away. But if I gotta use it, how can I rewrite this? It's so much clearer if I put the 4 on the top, the 5, and the 5th root of x on the bottom. Do you see how, this x to the negative 1/5 and this, the 5th root of x on the bottom, those are the same thing. This sticks out at me. I still don't care about negatives because it's a 5th root, but what do I all of a sudden care about? X cannot be what? What's going to cause a problem there? If x is 0, right? Yeah, go ahead, say it. It could be wrong. If x is 0, we got a problem. So x cannot be 0. When x is 0, it's not differentiable. And sure enough, 0 is in my range. So f of x is not differentiable. Is that spelled right? Yeah, okay. Not differentiable when x is, you could say when x is 0, or you could say on, you don't even have to say, just on negative 1 to 1. Oh, actually, technically it would be what? It's parentheses, right? Let's just write it like this. Negative 1 and 1, if that was a problem, we'd be okay. That's what we saw in the last example. But it's smack dab right in the middle, that's an issue. So it fails Rolle's hypothesis. Right? We cannot, so what are we going to put for C? We're going to put does not exist. Okay. But really what we're saying is, what did I write on that last one? I liked it. Yeah, it fails Rolle's theorem. Yeah, good. It fails, fails Rolle's requirements. Yeah, I like to see. And again, for website, you just have to put DNE, but just so that you understand why you're writing it. It fails its requirements, so we're not even going to go on and find a C. Could a C be out there? Absolutely. But according to his requirements, and that's all we're doing for today, directions say focus on his requirements, we're going to step back. Done. Mic drop, right? Let's go. Okay, so let's, tomorrow's won't be that long. So you want to do, so tonight do 1 through 5. If we get to 6, I just wanted to do a trig just so that we remember the derivative of trigs. But if we get to 6, we'll do it tomorrow. And if not, then I'll toss it. Also, the paper that was on here was always going to be for tomorrow. So we'll just see how far we get tomorrow. We want to do mean value theorem, but they're kind of related. So 1 through 5, and then the word problem, and 6. A word problem is going to be for tomorrow anyways, and 6, we'll just see how tomorrow goes. All right, so 1 through 5, we should be good. Why do we care about C's? That's where there's max and mins. That's this whole chapter through section 5 even. Yeah, even 5 is all about these maxes and mins. You guys can't see. Tape and I forgot. So 1 through 5, just make sure you do 1 through 5, and then it fails Rolle's requirements.